Kasra Shahmirza, Sanamohamadi, and Rayan Alghani, who are in grade 12 from Tehran International Adaptive School for Boys and also girls. And they'll be talking about the hydrogen engines. Please give them a round of applause.
Hello and good morning, everyone. Ladies and gentlemen, welcome. I am here to present to you hydrogen engines and its benefits with renewable energies also considered. First things first, can it go? Hydrogen, the origins of hydrogen. Well, you can see on the screen it says inefficient, inexpensive, and pointless. Why do I mean by that? It's inefficient. It originally made in 1966, Chevrolet made the Electro van, which was fueled with liquid hydrogen and liquid oxygen, both extremely flammable and dangerous components which you can have in a car. Why was it expensive? Well, as I mentioned before, this was technology that was new in 1966, basically never used except for space exploration, which meant extremely high prices, no efficiency, and what do I mean by pointless? It was dangerous. If anything, one of the prototypes exploded on site and left an exploded radius of nearly somewhere around quarter mile to half a mile of shrapnel you can find across. Okay, modern day questions. So what do I mean by this? Now, I just mentioned to you how hydrogen is dangerous, useless, and expensive. But we cannot just ignore it because of these reasons. Because we have things like climate change, we have renewable resources. Now, here we say lithium because our focus is going to be also on batteries. But other than that, our carbon footprint as humans and the bipolar nature of the car industry. We will talk on this about later as well. Okay, so alternative solution. Why do I say hydrogen is the alternative solution? Versatility. You see, why is it versatile? Well, we can have it as gas and as liquid, which means you can have cars that are already on the road, get pumped with hydrogen, and it will just run. You will need modifications, yes, but it would be the most cheap and efficient way to integrate it into society. What do I mean by viability? It's viable. Hydrogen is super abundant. It is everywhere. The single building block of the universe as we know it. Hell, when you look up in the night sky, there's hydrogen in the night sky. You look around you, you see people sitting next to you, that's hydrogen. You see me, I'm speaking, and the air in my mouth has 78% hydrogen. What do I mean by efficiency? Efficiency is, as we will tap into soon, originally hydrogen was not very efficient. It was nearly 100 miles per tank, but as we'll see soon, it will have a 2,000 kilometer mileage on a single tank. Now, enough about that. The pros and cons. Everything has pros and cons. Studying has pros and cons. Eating has pros and cons. Studying and as eating, as hydrogen has pros and cons. What do I mean by that? Okay, tap quickly. Okay, so there we go. Pros, longevity and lasting effect. What do I mean by this? See, due to its abundance of hydrogen and how easy it is to just grab it, although expensive, yes, but still easy to get it, it's extremely long lasting. So you can start now, let's say 100, 200 years from now, you would still have enough hydrogen that you won't even have to worry about it ending. The ease of integration within society. Like I said, you have cars like the BMW Series 7 Hydrogen 7 engine, which was a V12 engine that ran both on gas, petrol, and also on hydrogen liquid, which, although at the time still pretty inefficient, could run 290 horsepower, could get pretty good mileage, 125 miles on hydrogen, and about 300 miles on gas. Now, that's not the thing. Reduction of greenhouse effects and its global warming. What do I mean by this? Again, another thing. See, global warming, very apparent issue. You open your weather app on your phone right now, you can see that the upcoming days keep getting hotter and hotter and hotter to the point where you reach 40 degrees Celsius days where you're basically melting your head off. Cons, what do I mean by this? Well, like I just said, we just had a lot of pros, a lot of reasons to invest, but we can't just say, well, if it's this holy grail of technology, why hasn't everyone put their money into it? You see, these exact cons are the very reason. You see, it's expensive. At its core, hydrogen is expensive because getting it out of the thin air or getting it out of water or just anywhere of acquiring it is expensive, it is unresearched, it is undeveloped, and we need to work on that. What I mean by price of hydrogen is high. See, on the Toyota Mirai is a Lamborghini. Mirai, on the Toyota Mirai, the tank of hydrogen, the gas that you fill up, costs nearly $80 US to fill. It's expensive, it is, it really is. For the low mileage you get, $80 is a lot to pay for a tank. However, you have to also consider this, that $80, it will get subsidized by Toyota themselves. And, okay, Okay, so problems worth mentioning, the marketing incentives. Like I said, these are the exact reasons why we can't just say, oh, well, hydrogen's here, let's just all dump our money into it. Because you see, by 2050, although there are not much hydrogen gas pumps around the world for fuel cell vehicles, California plans by 2050 to have over 100 stations across its state. What does it mean? You drive anywhere with a hydrogen fuel cell car, you can always refuel it and never have that problem. Another thing, Toyota, as said here, will subsidize up to $15,000 for the first 3 years of owning its car on gas prices. Yes, so that means for the first 3 years, you're basically paying no money for gas, you're paying minuscule amounts for maintenance, because its maintenance is actually pretty cheap, and it also basically runs like electricity, so it's pretty fast. Anyways, problems with manufacturing, another thing, lack of infrastructure. These are the graphs for electric charging stations across the world, or well, here Europe and North America, but most of the world. So you see here, originally 2021, we didn't have a lot. It is predicted that as time goes on, not only do we have, as the blue line detects, house chargers, and as the last one, green chargers, DC fast, like the ones you see, like Tesla superchargers, they have increased as time went on. We can use such graphs like this, and also the fact that we see the electric industry started as nothing, bare on the ground, constantly got rejected, and currently, look, it's half of the world's market is electricity. However, we can, again, like I said, use these figures, use these graphs and statistics to understand that it's actually pretty good to invest early. Okay, and now another thing, power efficiency, range covered efficiency, refueling productivity, all of these things. What do I mean by these? So you see, when you have an electric car, sure, it runs basically like 400 miles, let's say, on a single charge, but it will take you 2-3 hours to charge it up. However, with a hydrogen car, you pump it like a normal car, and it gets the same mileage as the electric car because, again, you're using batteries to pump the car. So you look at it like this, you have the time efficiency of a gas car, you have the mileage of an electric car. The only problem, like I said, and I will repeat again and again, is cost, which with government subsidies and private companies working hand in hand, you can make that cheaper. Can we go to the next one? And potentiality, here. Matthias Ray, Volkswagen passenger cars technical chief, said on, well, it's pretty mocking to use Twitter as a source, but on Twitter, he claimed that hydrogen was such a pointless thing to talk about that he reclined. He basically got disgusted by the idea that people were asking him, well, are you going to use hydrogen in the future? But not a whole 6 months later, he signed a multi-million-dollar contract with piping company Kraftwerk to create a patent for a vehicle that can run 2,000 kilometers on a single charge, or tank, whichever one you want to call it. Now, there are 3 different ways you can pump a fuel station or have a pumping fuel station for fuel cell vehicles. There are 3 ways: gaseous, liquid, and on-site. What do I mean by this? So gaseous, these are all the names for how the hydrogen gets into the station and into the pump for going into your car. Gaseous, we deliver on-site with gas. So a truck comes in, has gas, compressed gas in it, you bring it, you put it underground, you wait until the car comes, you pump it up, you put it in the car, go, you're done. Another way, liquid. Liquid, what do I mean by that? So it comes into the station as liquid hydrogen, it gets pumped into underground through compressors, it runs through a machine, it turns into gas, and you get to pump it. Last thing, on-site. What do I mean by this? On-site is the most complex one and also the most expensive one, as you saw on stage, and I will say the net prices in a second. On-site, you use solar panels to use your electricity on-site. You then use that power you made to run water or different chemicals through electrolyzers, and you basically make your hydrogen like that. And as a last word, sort of my conclusion, the gaseous one costs $2 million USD to make, and with all the maintenance costs and everything considered, and $2.8 million for the liquid and $3.2 million for the on-site, with gaseous being the most cost-efficient and its return being 20% annually, about $100,000 a year. And as my citations and my finishing, thank you for listening. I hope you enjoyed my presentation, and that was it.
Thank you so much, Kasra.